What is up, everybody? You know, I always like to start this show off by showing love to those companies who help make this podcast possible. Guys, I want to introduce you to my newest sponsor of the show, my friends over at House Call Pro. I don't have my affiliate link yet, the landing page. This deal was literally signed last Thursday, so the landing page is not done, but I still want to give them their love. And if you happen to go and call them or reach out and say that, you know, you went through HVAC Uncensored, they will still give you whatever deal. I don't even know what the deal is yet. But with that being said, there's a free 14-day trial given to anyone. House Call Pro is a CRM or a customer resource manager, a field service manager, whatever you guys want to call them nowadays. But I really like House Call Pro, and I was one of their biggest critics. When I first got to Beltway, coming from Service Titan, I was like, oh, drop this crap. This is never going to work. You can't build a business on this. And I'm going to be honest with you. House Call Pro has done nothing but prove me wrong every step of the way. They keep adding feature after feature after feature, and they can compete with the big boys. You can run a legitimate business using this software for a fraction of the cost of what some of these other ones do. We use this at Beltway. We love it. And that's why I felt this was so good. I've tried to represent some other amazing softwares out there, but I don't use them. We use House Call Pro. I set the schedule on House Call Pro. I know the ins and outs of House Call Pro. So if I'm going to represent any software and for me to be true to who I am, House Call Pro is it. So if you are looking, any business owners, managers out there, or owners, if you're looking to take your company to the next step and you're trying to keep things organized, go check out House Call Pro, and I will provide that link by not Wednesday, probably by next week. I should have the link, and I will start passing it around. All right, with that being said, work simpler, grow smarter with House Call Pro. Next, guys, is my friends at BLUON, and if you have not went on your app and tried the Master Mechanic AI tech support, it is absolutely amazing. And like I tell everybody, just because I sponsor with BLUON doesn't mean they're perfect and don't make mistakes. But all I tell you is keep trying. I think what BLUON's doing is great for the industry. It's giving people a resource that they may not have had. Maybe they don't work for a company that has an amazing boss or somebody that's teaching them to do things the right way, and they have to learn by watching my guest videos that's coming on today. So that's why I love it. And I get some of you, you're all super techs. You know everything. You don't need tech support. You don't need help. Well, guess what? Some people do. And that's what BLUON is there for, to help the people who need it. They still have the on-the-phone tech support, the ordering the parts, all that kind of stuff. But this Master Mechanic AI tech support is very, very awesome. Obviously, like I said, the more descriptive you are in what you ask it, it's going to give you better answers. So if you just click on it and say, I'm standing in front of a furnace and it's broke, it's probably not going to give you the answer you're looking for. I have messed with this thing for a while now, before it was even out to the public, and I have literally thrown hard questions at this thing, and I found a few hiccups, which they're already fixing and making right, but I would say 95% of the time, this thing led me down the right path to be able to get to where I needed to be to solve this problem and fix this system. So go check out your BLUON app and check out the Master Mechanic, which is AI tech support. With that being said, let's get on with this pledge. We have an amazing guest tonight. Let's rock and roll. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. God bless the United States, and thank you to all those men and women who defend it.
Let's welcome your host, Gil KV Jr.
We're going to start that again. I was wondering why I couldn't hear anything.
5, 4, 3, 2, 1, go.
Welcome to the #1 rated HVAC podcast. If you're looking to grow in the HVAC industry, then you're in the right spot. Blue-collar people talking about blue-collar shit. Let's get better together. So turn up the volume, buckle your seatbelt, and let's welcome your host, Gil KV Jr.
What is up, everybody? Welcome back to the HVAC Uncensored podcast. I'm your host, Gil KV Jr. Here we are, a special episode on a Monday night. I got a great show for you. Sorry about that. This is where my daughter's coming here. It was muted, so I couldn't hear it. But anyway, we can cut that out in editing. Guys, an amazing show. I want to say this real fast. Normally, I try not to do shows when friends are doing live streams and stuff, but I have so many friends that do shows every night of the week. It's hard. I know my buddy Chris, HVACR Videos, is doing a live stream right now, which it was no intention of trying to compete. But with my schedule being mixed up, and when you get a guest like what I have tonight is, you got to make it work. So with that being said, I know some of you are going back and forth. You can listen to this or watch it later. You won't offend me if you want to go watch Chris's live stream. He's a good buddy of mine, so I understand. But anyway, guys, an amazing show tonight. It's an amazing week, to be honest. This guest, and then Wednesday, I have my old co-host, Kelly McKay, is going to come on, and we're going to catch up and see what he's up to now. But as far as tonight, I always look forward to talking to this gentleman. It was amazing that I've been able to meet him in person and hang out with him. And like I said, I think it's amazing what he does for the trade, for the industry. And there's no surprise that he has the following and as many followers as he has, because the information he gives out is absolute gold. There's nobody that you can talk to that watches YouTube and HVAC who doesn't know who this man is. So he needs no introduction. With that being said, please welcome Mr. Craig Migliaccio, AC Service Tech.
Gil, I really appreciate you having me on, man. I love talking with you, brother.
Yeah, man. Same here. I love having you on. Like I told you, it's been awesome to meet you and call you a friend, but as well as being a fan of yours and watching, all the stuff that you've done. Because I always tell people, I'm like, if you really want to learn this industry, I'm like, I can tell you a couple of channels you can watch that'll make you better. And yours is always the first one. Like people that work for me, watch your channel. They'll come in and like, oh man, he made this about ductwork and I learned how to do this. And I'm like, well, there you go. It's amazing. I always say at the end of every show, like if you want to learn something nowadays, there's no reason to say I can't, or because there's so many resources to you that if you want to know something, you could know it. You know what I mean?
Yeah, man. I really, like I said, I really appreciate you. I've contacted you in the past and said, you've been a big encouragement to me, and just how you care, how you treat people, and just how you communicate, and your care for the HVAC trade and those in it. So yeah, I'm glad to be here, man.
Thanks, buddy. Well, speaking of podcasting, your podcast has been out and it's been absolutely amazing. So what made you, because I know you're already busy with what you're doing with all the videos and stuff like that. What came about for you to, I'm going to start a podcast? Like, how did that happen?
So we, over the years, with YouTube, we've answered a lot of questions, comments that have come in on YouTube, and I found it to become too much. And I kind of had to stop trying to answer all of them. So there's only so many that I can answer. So what we did instead is we made a podcast section and a forum over at our website at acservicetech.com where people can ask questions there. And if we find questions that we feel are unique and things like that in the YouTube section, we kind of gather all those together and try to answer them in podcast format. And so I had my good friend Ty Brannaman over, and we answered a bunch of the questions. We put together several podcast episodes, and we're looking to make a new podcast basically every other week and put that out as well. But the object is to be able to help people wherever they're at. So if they're riding in the service truck, I just want there to be, questions being answered as they're driving down the road, and just thought and processes that can happen, during that time. And, they're listening to your podcast, they're learning a lot there. And I don't know why we took on another thing to do.
Yeah, no, I mean, I get it. I just wonder what it came about because I know all the work that you guys put into the videos and stuff like that. So it's awesome that you started a podcast. It's just more access to you, like we were talking about off air. Like, anybody would, if they get a chance to get more access to you and gain more knowledge. Because I remember when I first started watching videos, you go down that rabbit hole and you go through that phase where you'll watch everything, especially when you're learning something. And I know people do that with you. And I made a joke the other day. It was funny. I don't know how my oldest son's going to do in college with baseball. He's having a little rocky phase, but he's been looking at HVAC and he was like, yeah, Dad, he's like, I've been watching these two guys. And he was like, you probably know them. I'm like, actually, I do know those guys. And you were one of them. And he was like, oh, Dad, he's a big deal in HVAC with your bald man convention. I'm like, shut up, man. Be quiet. But it's amazing to see how many people watch your videos and grow from them. Like, I think you do, but realize how many people you've impacted when it comes to like learning from your videos. Like that's pretty awesome. Like people listen to me and I don't cover the X's and O's like you do, maybe some of the more technical stuff. And I would like to try to get into it, but I guess I never have because I don't want this to sound wrong. Because of guys like you that explain it so well, it's like, well, I can't explain it as good as them, so I just don't. But I think I'm going to give it a try. But I want to try to do more of the technical stuff. But as far as what you do and how many people you've helped, I think it's just amazing.
Yeah, I mean, I think we all feel that way. Like I was telling Brandon here that, he's like, hey, we can just get this other video out and this video out. And I'm like, man, I don't know if it's going to be good enough. I don't know if I'm good enough. Like you always have that thought. And so it goes to your point. You don't know what it's going to be like until a video is done. There's a lot of time and things like that we put into it. And it is very encouraging when we get to hear people's stories of the impact. That is really cool. I do miss, being able to do it in person more, just to have that face-to-face interaction and questioning and growth, like visually seen right there in the room. But it does take a lot to do the videos and the books and stuff like that. Of course, we do get to go out, and do the different conventions and things like that. So yeah, we're trying. AC Service Tech, we're trying.
Yeah. Nah, you guys are crushing it, man. So you guys are gonna be at AHR again, right?
Yes. Yeah, absolutely. We're going to do the podcast booth. We'll be there a couple times and we'll be going out to different booths and we'll send out a schedule, to let everybody know so we can meet up. And I do want to encourage people. I did hear a couple people say they thought we were busy and so they didn't come over and say hi. I really want you to come over and say hi and have a genuine conversation with me. I think that quality conversations matter and I'll stop what I'm doing to do that.
Yeah, those are awesome when people, I mean, so you people, the people who listen to him, I'm another influencer and I feel bad going over when he's talking to somebody else, but this is the chance that you get to meet people. AHR and these conventions has been amazing. How many, being able to meet you and so many other people, being able to meet different people, it's awesome because you can talk on these podcasts and then when you tie it in to meet in person, it's amazing the friendships and stuff that you can build from this. I love it. I've met so many people that I call really good friends that I talk to more than people who live down the street nowadays. Like my hat, Tersh Blissett. He's become one of my best friends. I haven't talked to him in a little bit, but I love Tersh to death. Him and his wife are the sweetest people you ever meet. But because of things like that, which is absolutely awesome. I guess I'm curious this. I know you get so many questions. What is probably like the biggest, if you had to pick like a range of like a topic that people ask the most, like, are they all over? Is it more like refrigeration based questions, like sequence of operation questions? Like, is there one that pops up a lot that you're like, I should make another video about this because I get the question so much?
I think they're all over the place, really, and it really depends on the season and the topical instances, and so a lot of times it's somebody doesn't know where to start, really, with like a gas furnace is not turning on and they don't see an error code or something like that, or it's intermittently working. Intermittent problems. A lot of people want to just know procedures, what we think is the best procedure, or what we think is, say, the best tool or something like that. There's a lot of vacuum procedure questions. There's definitely a lot of those. And there's a lot of manifold questions and mini split questions. That's what led us to make that book, really. They're all over the place. I couldn't land on just one, but sometimes it only takes one question to spark that creative juice, say, in me, to say, you know what, we could attack this from another angle, because we might have done a video that was related to it, but then I'll get an idea based on maybe on somebody's question on like how I could try to communicate this differently in a better visual way so that somebody can understand it. Like, one thing I'm thinking about right now is the condensate traps. I know it's not really that season right now, but like a package unit or air conditioning condensate trap, and how, if there's not water in it, it's not going to allow the water to flow out. But I think I have a better visual idea of something I would like to try to convey to everybody in reference to that.
I'm actually glad that you brought up mini splits, and I know that we didn't talk about this beforehand, so I hate to be on the spot. But speaking of mini splits, like, I get a lot of people that don't understand, like mini splits are very hard for them. So if you had to, like, some of the biggest myths that people think are harder than it is about mini splits, what would you say to simplify that? Like,
the myths, well, the one thing is, a lot of people they realize it's really easy. They say really easy to install. That's just to get it running. That may not be the best way to actually install it. And we need to be putting surge protection on, like right where I live at. We have like dirty power, what I would consider dirty power. And a lot of times, instead of it being 240 volts, it's like 255. And that's like normal. And so a little higher than that, you really need something to maybe cut off the power. Because it's just too high for the mini split to handle. But the other issue with mini splits is, what's worse, supplying slightly higher voltage than what's normal, or cutting off the power while the compressor is running and the IPM is supplying power, because then you have a shock, and it's like, either way, you're kind of messed up a little bit. But it does help to be able to, provide like that safeguard from excessive overvoltage, and then a surge will short it directly to ground. Like for a very short moment in time, like, some type of grid problem, or, electrical strike, like a lightning strike miles down the road or something like that, that might have messed with the grid or something like that. I'm not sure about myths.
That's
the
a
one
good
thing.
Though.
Okay. Yeah.
Yeah.
Another thing is line sets. There was a problem with with certain line set insulation, and really what it comes down to is the deterioration on the outside. You really need to add that extra layer of protection around the insulation, which is, you think it's protecting the line set, but really it's not. And so once the outside degrades, water can kind of travel through that, say, like open cell, foam insulation and stuff like that. And then the water gets stuck in the tubing. And so people are looking for that line set corrosion, basically from the line set cover to the unit. But really, it could be wicked all the way up the outside wall. It really does. It travels upwards. And you could have that line set corrosion up high. And so, like, line set corrosion is one of those things that people aren't really paying that much attention to, but you really want to wrap your line set with your nylon tape, or provide like some type of guard over that from the line set cover to the unit. Like Airex makes that layer of UV coated wrap that you can wrap from one point to the other. And so there's just different things like that, sealing the end of the insulation so it's not completely open, and try not to have it on a slant where water's going to immediately get into it, stuff like that. And then other things, the torque values and stuff like that. What's funny is every single manufacturer has different torque values. Yeah. Is that sad? Like, you can't even find a center point between, like, if you look at 1/4 inch and 3/8 and 5/16, and you just look at all of them and you can't even find a center number that would be good for all of them. That's
Yeah,
ridiculous, because
yeah,
it's a
that
heat
is
pump
ridiculous.
and it's R410A or R32. I mean, they're not that far off with the operating pressure. Sorry.
Yeah,
that's,
no.
that's a little frustrating.
No, I agree that is frustrating. And I know a lot of people have when there's like wiring things and people don't understand the codes because there is a lot of, resistors and, things in there that if, they go out and they're sensing their things. Like I had a guy that he would always go out and hey, this fan in here is running really slow. The people say it's not keeping up. And I'm like, it's probably a refrigerant problem. There's that little resistor that's behind the coil. If it's not sensing the proper coil temp, it's going to slow the fan down. But a lot of people have issues. There's a few questions. I saw some of your questions. Please make sure you put them in all caps so I can see them. But a lot of people have issues with charging. So I guess if we want to go over that properly, like once you get it and properly knowing what it's supposed to be when you go to check a mini split.
So yeah, you hit on a good point there, and that was making me think, oh yeah, we need to cover that as well. So presently there is no manufacturer that I'm aware of that gives you a target superheat on a mini split running, say, in air conditioning mode where it has just a single port on the vapor line. Nor does anybody give you a subcoin, but we'll get into that in a minute. That I'm aware of. I'm not, you could have another manufacturer come up with this because I've been mentioning it and other people have been mentioning it for a while. Like, why don't we, even when you have like the emergency cool button or emergency air conditioning lockout button, hey, that should lock the indoor metering, or I'm sorry, the outdoor metering device at a specific opening size, the compressor ramped up fully, the outdoor fan ramped up fully, and the indoor fan ramped up fully. But you don't really know what the percentages of those are. And if the accumulator tank in the outdoor unit or both accumulator tanks are fully drained of refrigerant in order to then check the refrigerant charge. Even further to that extent, they might want to be supplying outdoor ambient and indoor wet bulb temperatures as well when you're doing that, even though there's an EEV to give you, a target superheat. So number one, we don't have that. So what some guys are doing is they'll run around and they'll press that button, and they'll turn the power off, they'll turn it back on, they'll press that button, they'll let it run for like 5 minutes, and then they're trying to add a certain amount of refrigerant until they get to a certain amount of superheat because there's only one available port. And that might be, they might charge it from 0 to 5 degrees of superheat or 0 to 10 or something like that. But the problem is you don't know if all 4 of those components are at their full capacity. And that's the issue. So if you do accidentally overcharge the system, say it is an air conditioning mode or something like that, and then maybe it's in the summertime, maybe it's like 90, 100 degrees, but then it's fall or spring or whatever, or it's nighttime when you don't need as much refrigerant, it's going to gather in the accumulator. If you put too much refrigerant in accidentally, the accumulator tank's not going to have like way excess like of amount of refrigerant. And so what'll happen is it'll go over the tubes on the inside of the accumulator, and that liquid will come into the compressor and damage the compressor because it'll have liquid instead of vapor entering. So that's one thing. The subcooling is an issue because you can't, the EEV, there's only one metering device in a mini split, by the way, and so it's in the outdoor unit. And so if you're trying to measure quote unquote subcooling at the outdoor liquid line port, if you want to call it a liquid line, you're not going to get subcooling there because you have the EEV before it. So the EEV is going to lower the high pressure subcooled liquid to low pressure low pressure liquid, and a little bit of flash gas is going to be in that line. That's also another reason why we don't have a filter dryer on the liquid line, because there's not a steady location where there's going to be subcooled liquid refrigerant between heating mode and air conditioning mode, because there's only one metering device. If you think about a regular conventional ducted heat pump, or even some inverter-driven ducted heat pumps, a lot of them have 2 metering devices. So we're not talking about the mini split air handlers, that are still connected to the side air discharge unit that only have 1 metering device, but those that have 2 metering devices, the BiFlow liquid line filter dryer is in between both of them.
Yeah, no, that's because really on those, there is no true liquid line, right? Because doesn't it go back and forth between liquid and vapor mix just because of where the metering device is?
Yeah, so in air conditioning mode, you'll have traveling from the outdoor unit to the indoor unit. You'll have low pressure liquid and a little bit of flash gas. And when you're in heating mode, it's going to be subcooled liquid, high temperature, high pressure, subcooled liquid heading from the indoor unit to the outdoor unit. And so you don't always have high pressure subcooled liquid refrigerant. Sometimes you'll have low pressure and sometimes you'll have high pressure. And so you got to remember that in air conditioning mode, that's why we have insulation over that small liquid line. It's because it's low pressure and it's going to attract any humidity outside of the line onto the line. And so if that's occurring in the building structure, it's going to damage it because the water will drip off of that line onto the building structure and potentially rot it. So that's why you have to have both of them insulated.
And it's funny, at least around here, a lot of the counties and codes, municipalities, even for standard HVAC systems, are making us insulate both lines now. So now it's just kind of getting used to it. It's almost all the counties around here are making us do that. Do they have to do that up there for normal HVAC systems? Insulate the liquid line as well?
I haven't heard that really being enforced in our area in New Jersey, but it's all of that stuff is coming, and you just got to be aware of it. And the reality of it is, especially since we're now putting in more heat pumps, that's needed more anyway, just for efficiency reasons. So you're not losing the heat out of that line.
Yeah. So I know people do it, and I won't sit here and lie. I say that I never have. As far as when you are charging a mini split, most people say that you can't just add refrigerant, that you have to dump the charge, like recover it, see how much it is, and then weigh it back in. That is the way that you should be charging mini splits, correct? Like you shouldn't just be adding refrigerant because you're just guessing.
Yeah, you are guessing. I wish there was a clear, like almost like a sight glass on the accumulator. Like that would be cool. But there's not, and it would have to be a large sight glass, by the way, anyway, on the accumulator itself. But so it's not an excuse when somebody says, oh, on a mini split, you have to recover the refrigerant out and then pressure test it to try to find where the leak is. Or really, when you're recovering it, you're actually comparing the recovered amount of refrigerant to the factory charge plus any additional line set length that may have been added worth of refrigerant. So you're comparing that to the unit. So if it's low on refrigerant, then you need to pressure test it with nitrogen, try to figure out where the leak is on the system. Then release that nitrogen, vacuum out the system, do your standing vacuum test, or also known as the decay test, and then weigh in that exact amount of refrigerant again. So you're breaking the vacuum with the correct amount of liquid refrigerant from the bottle. So that is not an excuse. That's not, even though it sounds like somebody's maybe being lazy and saying that, oh yeah, that's it. That's the only way. Unless somebody can, show me a manufacturer's manual that on a mini split that says, we can charge it while it's live, which I will be in favor of. This is the only way that we can actually do it and know actually how much refrigerant is in that system. Unfortunately.
Yeah, no, that makes sense. Somebody, I got to say this real fast. Virgil Kane from Manchester, England. So thank you from across the pond there. And I know, one thing, and these might sound dumb questions, I just want to make sure that I give out the proper information. So I've always, especially on any inverter system, I always put on, whether it's ductless or standard, is surge protection. And that is good, right? Because it's true about, like you said, the lightning strikes, but even static electricity, like when there's those cloud-to-ground strikes, because to be honest, you hear some of the sales guys say it, and people think that it's just a sales tactic, but it is true. That does happen, especially in different areas, more so than others, doesn't it?
Yeah, you should definitely be installing surge protection. That the problem is if you don't, you could be installing a mini split or any equipment that has an ECM motor, like even the like the Gentech 2.3 and the 3.0s and even the X13s and the Broad Oceans and all of those other ECM motors are susceptible to having a problem occur, due to not having surge protection. And so that circuit board would fail. In a mini split, I feel like it's worse because that circuit board is very expensive, and it's harder to get than maybe having a replacement ECM motor that you could have in your truck and get that customer back up and running again. If you want to program one yourself, like a rescue version. But yeah, it's $50 component. It's not a big deal. Put it into the disconnect on the outdoor unit, or, even if it's an indoor unit, connect it right there by the disconnect switch. And definitely you want to do that. It's not that expensive, and it's just a matter of installing it. Now, I will say this, and this is frustrating. In the electrical code, we're not allowed to double lug, a wire. And so we'll put that surge protection usually on the load side, which is from the disconnect to the outdoor unit. And there's also another reason for that, is because a lot of HVAC master license holders and many states are not licensed to change out the disconnect or touch the line side.
Yeah.
Only the load side. So the problem with it is, in the disconnects, there's no like additional lug in order for you to like stick your wire. So then you're having to like cut your load wire and connect them there with either a WEG or a wire nut, which kind of seems silly, just in order to meet code. I would love to be able to just stick it in the lug and be done with it. But I wish the disconnect manufacturers would come up with a solution for this for us, because it's a major, major problem. Some manufacturers have built an all-in-one voltage monitoring and surge protection built into a disconnect. So that's great. That's nice. But I would still like to see some type of aftermarket solution for adding a surge protector to an existing disconnect box. That will make it easier.
Yeah, I agree. Because some of the ones where it's like surge protection built into the disconnect box, it cost-wise, it's just not feasible.
Yeah.
Because you could buy the disconnect and the surge protector, and the labor to install it is still less than what they charge for that disconnect box. I don't know if you've seen them, and I thought I had one here because I was messing with it. The little, they're supposed to be like little surge protectors just for like the ECM motors that you plug into them and plug. Do they actually work? I mean, have you ever tried those?
They have that PTC thermistor that acts as a current limiter. I think that's like at a lower value than what's in the ECM module. I could be mistaken, but I think that's what that is. Zebra
Yes.
makes that. Yeah. Those are nice. That would definitely help as well for those ECM motors. The other issue is like a lot of say like a furnace or air handler is completely communicating. So like it's not only just that like blower motor now. But yeah, that's definitely like a quick way to then end up protecting it, because that PTC thermistor, which actually acts as a current limiter, which would help. Or they might have surge protection, true surge protection ones. That's definitely something that you can add in there that would help protect that customer, because that's very troublesome, to have these ECM motors go down that often. And I've had ones that were like half horse and 3/4 horse that cost me like $1,200, my cost, in order to just to get it to the customer. That I didn't have a rescue version in the truck, and I had to order one from the manufacturer. Like, they can be costly, they can be a lot of money. Obviously, most of them are not that expensive, but that's kind of stinks just for some electrical problem that you as a HVAC technician or installer had nothing to do with. And that's also the very frustrating thing about what we're doing now is, we install this fancy stuff and it costs a lot, and then all of a sudden it breaks and it's not our fault. So yes, add the surge protection, add any protection that you can in there, because I don't want to be the guy going back, 2 months later with an upset customer.
Yeah, no, I agree. Matt Waxer, that might be what they're called, but Craig was spot on. The ones from Zebra are the ones I'm talking about, and you can get them at supply houses. They have them for all the different blower motors. So what we do is, when somebody becomes a club member, we have a package that includes all that. So I get the ones on the blower motor. We put ones inside, one outside. We use the little Rector Seal ones because they're smaller.
Yep.
They're easier. They're not all bulky to put on. So I was just curious. We use them. I was like, I don't know if they're helping, but they can't hurt anything. So that's why we put them on, just to help, because part of our plan is, if, while they have an active club membership, if they buy a new blower motor, they won't pay for it again. So obviously we want to try to protect it while they're under an active, because if it goes bad and then a brand new one, it's a 5-year-old, 10-year-old system, and we put in a new one and it only lasts 2 years, well, then we did something wrong, So we want to try to make sure that that doesn't happen. I was just thinking of something else and forgot what I was getting ready to say.
Yeah, I'd always add in that extra protection, because it's going to cost you. Like
Yeah.
if you're having to warranty it, you want to protect yourself as well as them, protect everybody. That's like the most frustrating thing for us, is when we take all of this care, for the customer, and then something happens and the furnace goes down and it's just not our fault. It's like, man, that stinks. So
Yeah.
you just got to be aware of all the different safety devices and things that you can put on, and how to not have the system fail. Like, it's just a lot more complicated, than the older systems where you had all the parts in the truck all the time and you could always get the system up and running. That was a long time ago, obviously, by the way.
Yeah. And you're right. And it's harder to get stuff. And when people buy these fancy systems, I always want to go back with OEM stuff. If it's a cold or a hot day and I got to put in, an aftermarket to get them running, then yes, I will. But I'm always going to come back with the OEM. If they bought a fancy communicating system, I don't want to downgrade it by now putting in some dumb motor. That to me, that's not doing a good job. I know some of the gas furnaces, I used to always want those little plugs, like I was talking about, for the motors, for the inducer motors, because some of those were ECM technology. So I was like, if we can get them little plugs for them, I'll plug on everything I can plug in, just to try to help. And so I'm glad that I asked you, because we've been using them. I just didn't know if they actually worked. And they're not that expensive. I think they're like $20-$30. So
I haven't like tested them to try to break them, quote unquote. I do that with a lot of things, try to, I just wait to see the tolerances, like to see how it works and stuff like that. And I do that also to try to explain how things work and how, just for people to be aware of them. But I have not done that with that particular part.
yeah, well, if you ever do, let me know, because I'd love to know the answer to that. The other question I have about some of the mini splits is when you replace the outdoor boards and they don't send the thermal paste with it. So, and then sometimes trying to find it is hard. I had a couple. Some manufacturers will, in the box, will come with like a little, just enough to be able to put that back on, and then others don't give it to you. And I think some people, if you don't know that needs that, they're putting in a board that's not going to last very long. That thing's going to heat up and it's going to blow again in just a matter of not that long.
Yeah, you definitely need to have that in the truck with you. And there's the mini split manufacturers, I don't want to say the good ones, but like the ones that are trying to reduce failure due to like dust gathering on the back of the coil or something silly like that, not providing the air, especially in the corner, like where the circuit boards are. When you have dust there, it blocks the airflow from being able to lower the temperature from the heat sink. So what some of the manufacturers are doing now is they are actually making a refrigerant circuit to end up cooling the board. And so they might do that even for 2-ton and even 3-ton smaller residential systems. And so they're kind of making it its own zone in order for the refrigerant to absorb the heat from the IPMs.
Yeah, no, that would be cool. I think a lot of times when it comes to ductless systems, everything is so smashed in. If you take the top off, like the board's upside down, that it's intimidating. And I know I was intimidated until I started messing with things. And to be honest, I messed up a few. I made mistakes. Thank God they were under warranty, but that's how I learned, because I was doing I wasn't sure. It looks like some of my friends over at the Misfits of HVAC, Mr. Jennifer Manzo and Ryan, they said, Gil, ask Craig if he'll come on the Misfits of HVAC podcast, which is Saturday nights. So there you go.
Yeah.
I asked.
Sure. Thank you for the invite. Yeah.
Yeah,
Just
they do an awesome show.
ask Gil for my contact.
Yeah, I'll hook you guys up. I'm a matchmaker.
Thank you.
It's like,
Oh,
the other thing I wanted to go ahead.
I did want to say one thing, if you don't mind. I was thinking about it earlier. When people are talking about subcooling and superheat, and they're thinking about single speed and 2-speed systems, and even VRF systems where you're monitoring all of these things, and you have pressure transducers and stuff like that. In these smaller residential, like commercial mini splits, what's actually happening is they're monitoring the temperature in both of the coils. They're monitoring the indoor temperature, the outdoor temperature. They're running the fan in order to circulate air, at least when you have a remote that's not a thermostat. And so they're making decisions for operation based on all of those temperatures. And so they're not actually always in locations where they're measuring superheat and subcooling, those thermistors. They're actually just finding the temperatures at those locations and working with the programmed parameters from the factory that produce efficient superheat and subcooling. And so it's actually working that way. And it's making adjustments for the compressor like that. And so like you might see a high superheat or something like that of like 20 or 30. If you see like 30 degrees of superheat or something like that on a mini split, yeah, you're most likely low on refrigerant charge unless the EEV is shut. Maybe it's rusted or the coils are burnt apart or something like that. Or they don't really jam up that much on the inside. Though I have heard of different people pressure testing them too high, and I guess the threads get stuck. I have heard of that several times actually, which is kind of funny, but it's an odd way for an EEV to break. But I just wanted to point that out. It's all of the thermistors and the pre-programmed algorithms on the EEPROM chips on the main board at the outdoor unit, and that's really how it's functioning. And so if you have those thermistors that are out of calibration, it's not going to be working very efficiently, and that does happen or can happen over time. Even just due to stretching on the wires and different things like that. And it's also a big deal when you see these outdoor mini splits are turned and the sun's beating on that outdoor air sensor, and it thinks it's warmer than it actually is. Outside, it doesn't operate effectively.
Yeah, no, that makes sense. I know we started a little late, so we're probably about 15 minutes left with a few more questions. One that I wanted to ask, and I've always been curious with some of these. I have a wiring one, but I'll remember that. I don't want to forget this other one. Mitsubishi has like the hyperheat, or these ones that in heat pump mode can go down to lower temperatures. Is that because it's just the compressor can run at higher RPMs? That's what makes that be able to do that? Or am I 100% wrong by saying that?
So the hyperheat units, regardless of the manufacturer, what they are is they're oversized units that are down derated basically. So like an 18,000 BTU one is derated to be a 12,000 BTU hyperheat unit. And the pre-programmed algorithms are only going to allow the system to operate at the 12,000 BTU level, like on an average, until it gets down to maybe 32 degrees or 20 degrees. And that's when, because the outdoor temperature sensor will monitor that outdoor temperature, and then the pre-programmed algorithms will unlock the full amount of refrigerant compressor capacity. So yes, in turn, it's allowing the compressor to run at a faster RPM, but it's only because it wasn't allowed to before, if that makes sense. So it's running at a lower capacity than what it's actually allowed to. It's not like the compressor is built differently or it's built better or to operate faster or anything like that. It's now allowed to operate, say, to 100% of its capacity, or maybe 110 or 120%. It's up at a higher amount, and these systems can even hyperheat systems, and they can even operate like at a full system capacity at even like like maybe 120%. Now they're all different, by the way. I'm throwing these percentages out. They're all different, but they may only be able to run at this crazy high percentage for a short amount of time before it then needs to ramp back down again. The other thing to think about is, and this is with all mini splits, is the defrost is like a lot more intelligent than in a standard single speed or 2-speed system. Like it can actually hold the saturated temperature in the outdoor coil above freezing. If it's like 33 degrees outside, it'll still be able to absorb heat from the air crossing the outdoor coil without being down at like 28 and 27 degrees and stuff like that, where it's actually going to have humidity come onto that coil and then gather frost on it. But also, I did want to also point out that when you do get down at a lower temperature, you have less humidity in the air because it's colder. It can hold less humidity. And so that's also a bonus, even though, you as a person, you feel cold, when you're outside and it's low temperatures, but there's still a lot of heat that's out there. I know I just threw out a bunch of things, and a couple of them didn't have to do with hyperheat, but the main thing with a hyperheat is they are a D-rated, larger size system that's now allowed to run at its full capacity when the outdoor temperature reaches a low amount, like 20 or 30 degrees.
Now that you said that, I remember being in the class hearing them say about the D-rated. So the way I explained it to somebody else, I was a little wrong. But after you said that, I remember that. I'm like, it's like putting a big block engine in a Toyota Tercel or something, like it just it's gonna blow up if it runs too long. And a lot of go ahead.
Yeah, another thing, and I forgot to mention this before, is I'm surprised that they would have even mentioned it, honestly, in the training, if it's a manufacturer training, because a lot of times what happens is if you look at the manufacturer's data of a hyperheat versus a standard heat pump, you'll notice that the hyperheat one at the same settings as a standard heat pump, like a standard inverter heat pump, they're less efficient at normal operating temperatures. So you don't want to just go slamming, hyperheat systems in every building that you have. You might be better off just installing a standard inverter heat pump system for efficiency's sake. But if you get really low design temperatures, and it all has to do with your load calc, and that's like a whole nother thing, with the mini splits. But you only want to install hyperheat pump systems when you have a very low design temperature outside. So that's something that you want to take into consideration. And to your point before, we can't remember everything. And that's why I was asking you, hey, what kind of topics did you want to ask or something like that? I'm like, I got to remember. I don't even know. I always feel like I don't have all the answers, and I need to, though. I'm expected to, but I don't.
No. I mean, and I know that I'm throwing things out, and your answers are more than enough. And I'm glad you said that about don't just install those for the sake of just installing those. Because I know when we're Lennox dealers now, and they have MLB is one of their outdoor units that is supposed to be like their version of hyperheat. And we have installed quite a few. But now it makes me want to go back and be like, hey, maybe, based on the load, that we shouldn't be installing these in every application for that reason. So, and the only reason they said it at our class is John, the tech support guy, comes to our shop, so I can have conversations that he probably wouldn't say, like, at their building, teaching a class to everybody. So that's probably only why he brought it up.
Which is good. I always wanted to get the details. I had, when I was teaching in the local county technical high school with the high school students and the adults, I would have some manufacturers reps come in, and I was like, but no, tell me the real details. Tell me the more so than the sales stuff, tell me the real stuff. And it was like pulling teeth trying to get that stuff out. So I'm glad that you have, the manufacturers reps, is willing to really go in depth with you. And it might be sometimes where they don't even know. I will also say, depending on the brands, sometimes the circuit board manufacturers are not the same manufacturers as the equipment. And so if the circuit board manufacturers tell the manufacturers of the equipment all their secrets, then the circuit board manufacturers don't have a job. And so therefore that means that the manufacturer reps don't have the answers, which means now we're like third or fourth in line. We're the technicians in the field. We don't have the answers, but we're expected to magically. So you got to keep that in mind too.
Yeah, no, that makes sense. I've almost wished that with the technology they have, that it could almost be like a communicating system, like in the Carrier Infinities or the Lennox, their communicating stuff, where you could see the refrigerant pressures in the thermostat. Like if you could have an actual thermostat for the ductless systems, and you could see the pressures and stuff like that in there. But that's asking for too much.
They can has some of that stuff, and so there's different brands that are doing that now, and it's all a matter of cost, right? So why does a mini split manufacturer not install surge protection when they know, like from the factory? And there's two reasons. Why don't they install if they know that their circuit boards are going to go down, and then all of a sudden they're magically going to have to warranty it? And one reason is surge protection isn't forever. It's not going to last forever. It's going to have a degrading effect basically, and it's going to have to get replaced. So they don't want to bury that and have that now be an extra manufacturer component. And plus it's going to drive up the cost. That's the issue. It's like we could have all this magical stuff in these systems, and you're going to have that more so on the VRF, like larger systems where you can actually see everything. But on these smaller residential systems, that's kind of like what's a little frustrating. And like I said, that's why, we put these couple years into that book, delving into all the different types of fan motor types that you can have, and all that stuff. So
Yeah, and the book he's referring to, if you guys don't know, two amazing books. His latest one is his mini split book. It is, if you want to learn mini splits, go look at that book. Like, I've read it, and it's helped me with so many different things. And maybe some of them, it's not even, like, I'll be honest, there's quite a few things that I just didn't know. Some things were good that now it's easier for me to explain to others. Like when I'm trying to teach my guys, I can put it into terms that make sense, that they're going to understand. So that's one thing I love about him is it's information, but it's consumable information, because sometimes you get books where it's great information, but you might as well be talking in Chinese, because you get fatigued by trying to learn. And I will tell you, not just because you're sitting here, that both of your books are very consumable to learn. Like, it's very good information that it's easy to learn, and it's not hard to like follow along.
no, I appreciate that. And the object or the problem originated when I was in the tech school, and I saw these big fat books that were like engineering language, and I'm like, oh, man, I'm having to press through these, but like I can't like sometimes I'm like, I can't imagine giving this to, say, like a 15-year-old kid that has learning disabilities and expect him to know, like, or her, hey, I expect you to digest this. It doesn't work that way. And so, what we do have a luxury of in the classroom is we can put them on take them over to a system, you can have them do some hands-on safe work